Again, your science teacher as well. And today we're going to look at SURDS. It is a mathematics class today, like we have done earlier, looking at logarithms without table and calculators. Today we are going to be looking at SURD, which is another type of mathematics that is a little bit technical. Now, before we do that, remember that this is a science class where maths, physics, chemistry, even biology to some extent is being taught in a very simple way. Okay, now you have to subscribe, you have to share, you have to as well follow. If you are on the Facebook, Dr. B Science Classes, when you get there, you share, ask them to follow. If you're on YouTube, it's still Dr. B Science Classes. When you go there, subscribe, share, ask them to also subscribe. That is your own contribution to this beautiful work that we are doing here. Now today, we are going to discuss SURD, and we are presented with a problem: solve SURD 24 times SURD 72 times 3 SURD 5. But what is SURD? Okay, what is SURD? SURD is not an acronym. SURD is simply a term that is used to describe basically square roots of numbers that are not perfect squares. Simple, all right? So like I said, SURD is not an acronym. It's only a term that is used to describe square roots of numbers that are not perfect squares. Okay, now if that is true, then how do we solve this? Before we can solve 24 times 72 times 3 5, we need to appraise ourselves a little bit of some rules that govern SURD. Okay, now there is a rule that goes like this, which is more like a product rule. That rule simply says that, rule 1, the rule simply says that where you have a SURD of x multiplied by a SURD of y, you can possibly join the SURDs together to have a SURD of x, y. You must make sure you understand the basics of this particular rule. And this is more like a product rule for SURDs. And now this can easily be explained like this, that if you have a SURD of 9 times a SURD of 4, you can easily make it one SURD of 9 times 4. But of course, the SURD of 9 is 3 times 3. So where you have the same SURD, you pick the integral number. So it is equals to 3. Okay, now the SURD of 4 is simply SURD 2 times SURD 2, because 2 times 2 is 4. Because they are the same, you can easily pick 2 out of them. So it means that this SURD can simply be given as 3 times 2. And this will give us 6. So it means that SURD 9 times SURD 4 is 6. That is what the first rule of of SURDs simply explains. Okay, now if we understand what the first rule of SURD explains, then we can also look at another rule of SURD, which is a quotient rule of SURD. Okay, now if you look at the quotient rule of SURD, it simply said where you have SURD x divided by SURD y, that it is the same thing as saying SURD x divided by y. That is the second rule in terms of its quotient rule, okay, for SURDs. Okay, so if you had, for example, if you had SURD 16 divided by SURD 4, it simply means that you can possibly have SURD 16 divided by SURD 4. But of course, if you divide 16 by 4, you should have SURD what? SURD 4. And of course, SURD 4 is 2 times 2, so you can have SURD 2 times SURD 2. Since they are the same SURD, you take the integral number as 2. That is what the second law, the second rule for SURDs explains, as far as the quotient rule is concerned. I am introducing us to a few of these, believing that we do not have the background before we can solve this problem that we have facing us. Okay, now there is another type of rule that defines SURD. Now you have a rule which says that when you have SURD x plus sort x, that this is simply 2 of the sorts. Therefore, it is 2 sort x. Okay, just like x plus x is 2x, the same thing when you have sort x plus sort x, it should give you 2 sort x. That simply means that if you had had 3, okay, sort 3 plus sort 3, you should have 2 sort 3. That's what it means. Now, these are basic rules that govern sorts. If you do not understand these rules, you'll find it difficult for you to solve sorts. Okay, now another rule is there which simply says that if you have sort x multiplied by sort x, where they are neutral sorts that are given to you, you should know that you can have x times x to give you square, so you can have sort x square, because this times this will give you x square, and we take one sort. So remember that if you remove this square root from here, it will give you 1 all over 2. That is a half. This is the same thing as this. So we will now have x raised to power 2, 1 over 2. Okay, which is something like 2 all over 2, x 2 all over 2, which is equals to what? X. That is another type of law, another rule for what? For sorts, solving sorts. Now, all these rules are very important while trying to solve sorts. Without having an idea about this, it becomes a little bit difficult for you to go through solving sorts. And that is why I am taking my time to let us know these rules that govern sort before we solve the problem that lies before you and I. Okay, now these are some of the rules I'm going to introduce you to in the course of this. Now there is another rule, rule 5, which says if you have A sort x and then you have times B sort x, that what you will be having here is that these factors that are out will multiply themselves, so AB to the sort of the ones inside, which is x. Okay, that means should you have 2 sort 3, okay, multiplied by 3 sort 5, so it means that 2 will multiply by 3 to give you 6 to the sort of what? 3 times 5, which is what? 15. That is the sort of 3 times 5, which means we can have 6 to the sort of 15. That is what it means. All these rules are very important in the course of trying to solve for sorts problems. Now, believing that I have been able to at least introduce you to 5 of these rules out of the 7 rules we have governing sorts, we should be able to use these rules that I have introduced us to solve this problem. Now let's go. Now let's solve this problem that lies before you and I, and solve. Quite an interesting topic in mathematics. Okay, now we are asked to solve this problem that lies before us. To solve this problem, it is important that you understand your mathematical table. If you don't know how to multiply numbers, it becomes a bit difficult for you to face this problem. Remember that 24 can be 2 times 12. To solve this problem, we take it part by part. So first, we are going to take this part first, which is the 24. Okay, now know that so 24 is equals to 2 times 12. This is the first rule in solving sorts, which I had introduced to us earlier. And this sort can be separated to sort 2 times sort 12. Do you know that sort 12 can also be 2 times 6? That means we can also have sort 2 times sort, okay, times sort 2 times 6. Which means we can also have sort 2 times sort 2 times sort 6. Okay. But we can still break this down to 2 times 3, which is 6. So we can possibly have sort 2 times sort 2 times sort 3 times 2 times 3. And that will give us 6. We can continue by expanding the sorts to give us sort 2 times sort 2 times sort 2 times sort 3. Of course. Now, where you have the same sorts, remember that we had this even in our first rule of solving sorts. When you have the same sorts, you pick the integral number to represent the sort. So this is sort 2 times sort 2 times sort 2 is still 2. So we can now say this is 2 sort 3. This is the answer for sort 24. This is the answer for sort 24. Now, we look at sort 72. Do you know that 2 times 36 is 72? Okay, so it means that sort 72 can be sort 2 times 36. That's what it means. And so this can give us sort 2 times sort 36. But we can still sort out sort 36 because I know that 6 times 6 is 36. So we can still have sort 2 times sort 6 times 6 to represent 36. And this can be sort 2 times sort 6 times sort 6. Do you know that sort 6 and sort 6 are the same? We can take the integral sort. And when we take the integral sort, it means that we now have what? We now have 6. That means this will be 6 sort 2. And this is the answer for sort 72. 6, we take one of it, the integral number, by sort 2. Okay. But we cannot solve this because this is already the solution to a particular sort you and I do not know. So we can't solve this. It's already solved. It's a solution. So we are now going to put this solution to this solution to this solution. Let's see. This means that, therefore, for 24 is 2 sort 3 multiplied by, for 72 is 6 sort 2 multiplied by 3 sort 5. This will take us to talking about the fourth law or the fourth rule of sorts, which says if you have A to sort X times B to sort Y, it means that you're going to have A times B integral numbers outside the sort to give you a total sort of multiplication. So this is what I mean. From here, it means we say if we have A to sort X times B to sort Y is equals to A times B to the sort of X, Y. That's what it means. And if that is true, then we can, as a matter of fact, link this to this. So it means that we have 2 times 6 times 3 to the sort of 3 times 2 times 5. That's what it means. That is what this means. Okay, and if we have 2 times 6 times 3, of course 2 times 6 is 12, and 12 times 3 is 36. Yeah, 36. So it means that this will be 36 to the sort of what? 3 times 2 is 6, and 6 times 5 is 30. Okay, it's 30. So it is 30. But do you know that 30 can be further solved? Because this is not a solution. 30 is simply what? 2 times 15. You can even say 10 times 5, you get the same answer. You can say 2 times 15, you will have the same answer. And if it is actually that, it means you have 36 to the sword of, that is 36 to the sword of 30 is equals to 36 to the sword of 2 times 15. Okay? So it means that we can possibly have 36 to this sword, to this 2, to the sword of 15. And 36 times 2 is 72 to the sword of 15. And this is the solution to this problem that we have here. Very simple, very, very simple. All you needed to do is to follow diligently, step by step, the solving of this problem, linking it to the rules that govern SURD. Now, for the sake of clarity, let me quickly re-explain what I have put down here. So we have solve SURD 24 times SURD 72 times 3 SURD 5. You have to break them down to be able to solve them. And here we want to solve SURD 24 following the rules of SURD I have given you earlier. So SURD 24, you look for numbers that can multiply by another to give you what? 24. And we said 2 times 12 will give us 24. Following the first rule of SURDs, we have this. This means SURD 2 times SURD 12. So 12 can still be multiplied. 2 times 6 is 12. So we do it. So we have SURD 2. 2 times 6 is 12. So we bring them out of the general SURD. We now have SURD 2 times SURD 2 times SURD 6. But SURD 6 can also still be multiplied. There are still numbers that can multiply effectively. 2 times 3 can give you 6. So we bring them out to have SURD 2 times SURD 2 times SURD 3 times 2. Split this out of the brackets. Out of the SURD form, you have SURD 2 times SURD 2 times SURD 2 times SURD 3. Because these are the same SURDs, you pick just one integral number. So this SURD 2 times SURD 2 times SURD 2, we take 2, not SURD 2, just 2. So this means we have 2 SURD 3. Since we do not have numbers that can multiply effectively to give us the SURD, the numbers must not allow us to have results that are in decimal points. You must take note of that. Now, that is done. We have to look at SURD 72. 2 times 36 is 72. So we split it out of the SURD, out of the combined SURD form. And then 36 can still have a number multiplied by a number. And that is 6 times 6 is 36. So we have SURD 2 times SURD 6 times 6. And then 6 times 6 can be split out of the central SURD form. And you have this way. But SURD 6 times SURD 6, they have SURD 2, 2, 2, we pick 2. The same thing, SURD 6 will give us just one integral number, which is 6. It's the same. So we now have what? 6 SURD 2. This is a solution of a SURD. We cannot further multiply 5. So we now take this SURD for this times this SURD for this times this. We have this. Following what we said was the fourth rule of solving SURDs, numbers outside should be multiplied by themselves. And numbers inside multiplied by themselves. In that way, 2 times 6 times 3 gave us what? And then 3 times 2 times 5 gave us the SURD. And this will give us 36, and this will give us 30. 30 can still be solved as SURD. So 2 times 15, or 10 times 20, or 10 times 3 can still give us 30. I choose to solve with 2 times 15. You can choose to solve with 10 times 3, you get the same answer. Now, we split this SURD out, and we have 2 times 15 for SURD 30. The SURD 2 will come out, and 15 will remain. So we now have 36 times 2 to solve 15. Okay, and this is 72 to solve 15. But should you want to still continue, because even solve 15 can still be solved as 3 times 5. So should you want to continue, you can still continue by saying 72 times 3 solve 5. Okay, and that will still give you the answer. I want to believe that you have enjoyed this part of the class, trying to solve this solved problem. With this, you'll be able to solve some other solved problems that come your way. Just take a good look at your textbook or some question papers in WAEC, or even some question papers outside WAEC, and look at